Hello, in this video of engineering economics we will talk about simple and compound interest. We will briefly describe simple interest computations just for reference, since in practice most computations are performed with compounded interest. First, let's consider simple interest. The formula that we have for simple interest is described in this equation, and let's see how we can use it. Let's consider a simple interest. If we have, say, $1,000 in the bank, $1,000 in the bank, and the bank is paying 10% per period, maybe 10% per year. This would be the initial balance. Now the interest that the bank is paying is 10%. In over 1 year we will have $1,000 we originally had plus $100. That is, the value that we will have in the future would be what we have in the present, $1,000 times 1 plus 1 time the interest rate. Remember, the formula originally was 1000 F equals P times 1 plus N times I, like that. And how much money we would have if we have it for say 3 years? Then we will have F equals 1000 times 1 plus 3 times 10%. That is, of course, 1000 times 1.30, and the future value would be, the present value would be $1,300. Of course, a smart person would think that they could do better if they decide to make 1 year contracts, because now, at the end of each period, the complete balance, that is, the capital investment and the interest accrued, could be part of the capital at the end of the period. Therefore, the gains due to interest compound, as the interests of the previous period generate more interest as they have become part of the capital in the latest period. Let me explain. If we are smart and we notice this contract, as opposed to having a 3-year contract, what we could do is we could have 3 times 1-year contracts, and therefore the balance that we would have would look like this. The future value at t equals 1 for the first year would be $1,000 times 1 plus 1 times 0.1. Of course, this future value is now 1,100. Now we can reinvest this result by computing the future value that we will have at t equals 2 is what we had at the beginning of t equals 2, which is 1100 at the beginning of the second period, plus 1 plus 1 times 0.1. Again, we're going to have a contract for 1 year, and we can make 10%, but now we're making 10% out of 1100. So the total amount that we would have at the end of t equals 2 would be $1,210. And we can further again compute now how much we would have at t equals 3, and that amount is 1,210 times 1 plus another year, making 10%. This final result, t equals 3, would be $1,331. Now if you compare 1,300 to 1,331, it's clear to see that we have advantage on using compound interest rate for our computations, because clearly if we select properly the periods, we would get a better result. So in general, and anyone that is using simple interest can turn it into a compound interest just by selecting properly the periods for the contracts. That's why in practice everybody uses compound interest. So this simple interest we will not use other than to explain it at this moment, and for the most part we will be using the compound interest. So as we saw, for computing the compound interest, all we need to do is we need to take into consideration one period and then take into consideration one period at a time. However, we also notice that we could probably, since this period, one period at a time is repeating again and again, we can take advantage of this repetition by using exponents at the time of doing our computations. For instance, the formula that we have for compounded interest is f equals what we have today times 1 plus the interest rate now raised to the power of n. So for that 3-year investment, we would have the future value equals $1,000 we originally had times 1 plus 0.1 to the 3. When we do the math associated to that, we would get 1,331, which is the same answer we had before. So this is the single most important equation that we will use during the course. Of course, we can obtain the equivalent notation for the present value if we would knew a future value, as the present value is the future value times 1 plus the interest rate to the negative n, where n represents the number of periods associated in the model. So in summary, in this video we covered simple interest and compounded interest, and why is it that we will continue to use compound interest for the remaining of the course. Thank you very much.